The environmental impacts of concrete and how we can prevent them.
By Sommerfeld, Anas Briki and Yuvraj Wadhan.
In this project, we will be addressing the following UN goals: industry, innovation and infrastructure, sustainable cities and communities, responsible consumption and production, and climate action.
Setting the scene. Concrete is vital for modern infrastructure, including buildings, roads, bridges and dams. Its strength and durability allows structures to last for decades while supporting heavy loads in constant use. Around 30 billion tonnes of concrete are used worldwide each year. This enormous demand, driven by urbanization and population growth, makes concrete the second most used material on Earth after water.
Concrete is also relatively low cost, widely available and can be shaped into many forms. Its excellent compressive strength makes it difficult to replace in large-scale construction projects. Most concrete-related CO2 comes from cement production. When limestone is heated in kilns, it chemically breaks down into lime, releasing carbon dioxide. This process is fundamental to making cement and cannot be avoided using traditional methods.
Cement production generates around 8% of global carbon dioxide emissions. This is more than the entire aviation industry and comparable to shipping. Due to the massive scale of concrete use worldwide, these emissions accumulate extremely quickly. These emissions contribute directly to global warming and climate change. Rising temperatures increase extreme weather events, sea level rise, and ecosystem damage, affecting both human populations and natural systems worldwide.
A short-term solution to this issue is the use of low-carbon concrete. Low-carbon concrete uses SCMs, supplementary cementitious materials like fly ash or slag, to reduce the cement content in concrete by 15 to 50%, and can also reduce the price if the materials are locally available. However, there is a major problem with this solution. Coal power plants, which are necessary to produce fly ash, are harmful for the environment, and as we shift to more renewable energy sources, we will see many of these shut down, which will limit supply, if not completely stop it.
Furthermore, huge steel factories, which are where slag is produced, are scarce, so supply is already limited. So while these are good solutions now, we need a more long-term solution. However, one last way to get these materials are in landfills, which decades of coal productions have left as stockpiles of fly ash.
Calcined clays are a much more promising long-term solution. This works by heating common clay, dirt, to around 700 degrees Celsius, which is considerably lower than the 1450 degrees Celsius required to heat limestone in cement. This makes the clay chemically active. It can then be mixed with limestone powder to make LC3 cement, which can cut carbon by 40%. Clay can be found almost everywhere, so this is a very easy and cheap alternative to standard cement. But what are some ways we can make this the cheapest, easiest, and smartest choice for everyone?
We could urge the government to introduce more carbon taxes, update building codes, and set a carbon limit for state-funded projects.
We could encourage investors to help fund the first of these projects to lower the risk.
The government could provide grants or tax breaks to encourage people to invest in this new market.
We could also encourage companies to set carbon targets on projects.
Finally, we must raise public awareness about traditional concrete's environmental impact and promote its low-carbon alternatives.
Thank you for watching. Together we can turn our environmental challenges into solutions and transform the concrete crisis into a foundation for a safer and healthier future.
By Sommerfeld.
Anas Briki
And Yuvraj Wadhan.